Everyone, and welcome to our WebEx today entitled Hierarchical Queueing Framework Overview and Changes on Our Quality Services. We're glad to have you with us. Just a few housekeeping notes to begin. When you entered the room, you either joined us by audio broadcast or by teleconference, which was automatically muted. Because of the large audience in attendance today, we're going to keep the phone lines muted. If you have any questions, please feel free to use the Q&A panel that's located in the lower right-hand corner of the console. Please use the chat window if you're having any technical issues and you'd like to talk to or chat with one of our facilitators, and we can walk you through any problems you're having. We're also going to have some polling throughout the presentation. That will also happen during on the right-hand side of the console. So when you see one of the polls come up, please answer, and then the results will come up automatically about 2 minutes once the poll closes. With that, I'd like to welcome again everyone and introduce our first presenter, Francine. Francine, the floor is yours.
Thank you. Hello and welcome to the Cisco Support Community. Today we present a live Cisco Support Community Expert Series webcast. Our topic today, Hierarchical Queueing Framework Overview and Changes on Quality of Service. My name is Francine Richards and I am a project manager for the Cisco Support Community. Our expert joining me today is Sarala Akella. Sarala is a customer support engineer at the Cisco Technical Assistance Center. She currently works in the WAN team where she focuses on various WAN-related issues along with QoS issues on various interfaces. Akella has been with Cisco for 11 years and has worked as a software engineer in the Network Software and Systems Technology Group. She holds a master's degree in computer engineering from Santa Clara University and a master's degree in mathematics from Osmania University in India. She also holds CCIE certification number 29921 in routing and switching. Now, I'd like to briefly outline the format for today's Expert Series event. Sarala will start with a short presentation on HQF overview and changes on QoS for the first part of the program, and then we will dive into the live question submissions for the remainder of the event. During our live presentation, you may submit questions to be answered by our expert and a team of Cisco technical experts using the Q&A box on the right-hand side of your console. The team of technical experts is well-versed on the subject, so please begin posting your questions now to give us the best chance of answering them. If you experience any technical issues, please post your question in the chat. We'll be asking polling questions during the webcast, and we highly encourage you to participate by answering them. Some questions will help our expert understand how much you're getting out of this presentation. You may download a copy of today's PDF presentation using the link in the chat window. And now let's get started with today's event. We're going to start with a polling question for the audience. What is your level of experience with QoS? A, no idea what is QoS. B, I know some basic QoS concepts. C, I know some basic QoS concepts, however, do not have any deployment experience. D, I know most of the QoS concepts, topics, issues, and have deployment experience. And E, I'm the QoS guru. What do you want? So if you take a moment to answer that question. And I want to encourage you to submit your questions as we will answer them a little bit later in the webcast. Now I would like to hand the mic over to our expert, Sarala, who will give you advice on HQF overview and changes on QoS.
Thank you, Francine. Thank you, Francine, and welcome everyone to Cisco's live webcast. It's a great honor to talk to such a wide audience tuning in from around the world. Today, while driving to work, I noticed that there was a Mobike which was trying to compete with the 16-wheeler because the 16-wheeler was very slow. And once the Mobike managed to come in front of the 16-wheeler, it just cruised through. It could go very fast. So the same concept here. Today we'll be talking about quality of service, hierarchical queuing framework. So the idea behind is how we can send delay-sensitive smaller packets without queuing them behind larger packets, so that the real-time traffic can go faster. So the same concept. So let's take a look. So today we'll be talking about hierarchical queuing framework and changes on the QoS after the implementation of HQF. Today's agenda, first I'll introduce what is like refresh quality of service, and then we'll go into hierarchical queuing framework, and then we'll go over some of the feature changes that happened in the later parts of after the HQF implementation, and then we'll answer any questions you have. Introduction to QoS. So the first thing in quality of service is we classify the traffic, like the interesting traffic. We try to collect them in classes, and then we either mark, police, or do something with the traffic. So I see that answers for the polling question. I see about 37% of the people know QoS, so that's very good. So we'll just cruise through the refreshing part, QoS refresh slides, and then I'll get into the HQF slides. So yeah, with the classification, our intent is to classify the traffic, interesting traffic, and then mark it or police it depending on what we want to do with that particular class. So the class, in the class maps, there are like two things we want to note. First is match any and match all. Match any is like an OR operator where, like if we have a particular class where we are matching DHCP setting EF, and we want to also select the destination address, then match any will do like an OR operator. So we'll be able to select all the traffic that has DHCP setting EF and also the destination address. So anything with EF match or with coming from a particular destination address, we should be able to match the traffic. Whereas match all is like an AND operator. We'll be able to match only if both of the matches hold true. Like only if the DHCP setting is AF41 and also the traffic has to match access list 101. That's when it will be able to match. So if we don't give anything, like if we have class map temp, then it will be match all by default. So we want to just make sure that we explicitly give match any if we want to configure a more open kind of classification. So the next slide, once we finish classifying the traffic, we want to mark the traffic, or we want to allocate the required bandwidth for that particular class. So marking we can do once we call the class, we set the DHCP marking in the policy map, and bandwidth, then we can give the bandwidth required for each class. For example, here gold, I'm giving a bandwidth of 30, and for silver, I'm giving a bandwidth of 20. I just want to introduce a concept here. Suppose 50% of the bandwidth is we are using for gold and silver, and assume there is no traffic on voice, and 50% is available in the class default. In the earlier versions, we were able to allocate the remaining bandwidth with 3:2 because we have assigned 30% of the bandwidth to gold and 20% to the silver. So our remaining bandwidth, whatever 50% is available, we would go with 3:2 ratio. But this behavior is changed in the later code, which we will see in our next slides. So the basic concept of QoS is to classify the traffic, identify the traffic which we want to work on, and then either give bandwidth or drop the traffic if it is not needed, or if it is going over and congesting the network, and then we can police or shape or do whatever we want to do with that particular classified traffic, and then we apply that service policy on the interface. Bandwidth. So bandwidth is, at the time of congestion, we give minimum guarantee that we will be able to send that particular traffic. Suppose I'm reserving 1 Mbps for voice, so at the time of congestion, I I'll be able to send voice traffic or video traffic for 1 Mbps. Police, we do it mostly for the TCP kind of or FTP or any traffic which we want to avoid. So it is going to limit the traffic, so we can't go beyond the policing rate. Suppose I police at 1 Mbps, I will not be able to go above 1 Mbps. And the shaping, with the shaping command, we give maximum, like how much maximum we can burst. Suppose I put a particular class to shape around 1 Mbps. That means I'll go up to 1 Mbps and then I'll slow down. I'll throttle back so that the extra traffic will go at a slower pace and will continue to send. So we kind of shape it, but we don't immediately drop the traffic. Priority here, it's intended for low latency, delay sensitive traffic. And when I give band priority command, like I give priority like 128 kbps, that means I'm giving the bandwidth 128 kbps and I'm policing the traffic, and also I'm sending the traffic at a very low latency queuing, that is very delay since there's not going to be any delay, so the traffic will go on priority. So I have some customers ask me, like, why do we apply the service policy directly on the physical interface? I don't see any error message, but when I take the same service policy and apply it on the sub interface, I see the problem. So I just wanted to bring that up. Yeah, on the sub interface, when we apply, we need to apply it as parent-child policy, and the reason being, for the physical interface we always have the bandwidth available. Like on the fast Ethernet, we know that it's going to be 100 Mbps. If it's a serial interface, it's going to be 1.5 Mbps. So we know exactly what the bandwidth is. On the sub interfaces with MPLS, we have to go in and say, okay, this is the available bandwidth, this is what the provider is giving. So basically we shape the outer pipe here, what it should be, like 128 kbps or 15 meg, whatever that. So we shape this outer pipe and then call our service policy, which is this, in the child. So basically we have our service policy, we call it under the parent and then apply the parent under the sub interface. Now we kind of refreshed our QoS concepts. We'll get into the hierarchical queuing framework. HQF, a hierarchical queuing framework, is a scalable infrastructure that supports a set of QoS features like low latency queuing, guaranteed bandwidth, WRED, and other concepts. So it's basically the same QoS concepts, but done on a more scalable infrastructure. With HQF, we have multi-level support now, and we can configure the QoS on physical interface, on the logical interface, and at a class level. So the philosophy behind here is to share the common aspects among all levels, and also manage the differences by tuning the parameters available. We take the scheduling parameters like minimum bandwidth, the minimum guarantee, which is the bandwidth command, maximum rate, which is a shaper, the outside shaper or a shape in a particular class, access sharing ratio, which will go in detail. This is a new concept which was introduced after HQF. And then priority level, we can have multiple priority levels, and it's the same behavior is the same. The traffic will be sent at a low latency queuing with an inbuilt policer in it, and the statistics and the way they are displayed are more consistent, and there is a clear separation between the control plane and the data plane handover internal to the router. HQF is supported on WAN interfaces like SIP200, SIP400, and on various POW modules. Also on 7200, it is supported from 12.0 train and 12.420T train. It is supported on C10K and various other low-end platforms. So I'll just refresh some of the concepts here. LLQ is nothing but a low latency queuing, and voice, it's mostly designed for delay sensitive traffic, which is we can configure this with priority command, and the unit is either kilobits per second, or we can give percentage or percentage in terms of the complete, if we take the complete available bandwidth as 100%. And bandwidth command is minimum guarantee at the time of congestion, how much traffic I can send for a particular class. That's what I can reserve with the bandwidth command. And I can always go above if there is available bandwidth. Shape average is used a maximum how much traffic a particular class can send when there is no traffic, but there is no minimum guarantee we'll be giving with the shape command. Fair queuing, flow based, this is more for earlier when we wanted to send interactive traffic behind the queue, like hold the data traffic behind and then send the interactive traffic before the queue. So we used to use fair queuing at that point a lot. WRED is basically congestion avoidance mechanism used for dropping the traffic so that we can avoid congestion, and we configured with maximum threshold is when we start dropping all the traffic, but minimum threshold is where exactly we start dropping the traffic, and we can always mark a drop probability that will give us how much a particular packet would be probable to be dropped. Queue limit is a mechanism to hold the packet under a default class, or where we want to kind of buffer the traffic and slow down and send the traffic, mostly used for TCP kind of transmissions. We'll take an example here and go over some of the concepts. So suppose I have a physical interface with 10 Mbps available, and I'm configuring priority %10. That means my voice traffic I'm giving priority %10. So I'll have an implicit policer of 1 Mbps. That means I cannot send more than 1 Mbps, but my voice can go at a priority queue where there is no delay. And I have a class called gold where I'm giving the bandwidth to be 30%. So I'm giving minimum guarantee of 30. At the point of congestion, I can send up to 30 Mbps. But if there is no traffic, I can go all the way up to 10 Mbps, which is the bandwidth available. And silver class, I'm giving a bandwidth % of 20, which is 2 Mbps, and let's suppose there is bandwidth available here. Like in our earlier version, we were discussing suppose there is 50% bandwidth available, then the way the packets would, we can send the available bandwidth to be 3:2, right, in the earlier versions of the code. Now this behavior has been changed. The excess percentage will go only, like it will be divided equally among all the classes which are available. So now my gold class will get can send one packet, and the silver can send one packet. So it will be basically divided into ratio of 1:1. Suppose I have 4 classes, I'll be able to send 25% each of the available, which would be 12.5%. We can tweak that parameter of sharing the available bandwidth by a command called bandwidth remaining ratio. I'll not go over this voice and all because we have covered those on the earlier slide. So the bandwidth remaining ratio. Suppose my bandwidth remaining ratio is 10. That means my excess, how much I can send through the default class, if bandwidth is available, would be 1 ratio. And here I didn't give bandwidth available as nothing for the gold class, so that would be 1, and here I'm giving bandwidth available ratio as 10. So this would be 1:10, and for the other class, if it was configured 20, it would go at 20%. So basically 1:10:20. And I also want to bring, see here, maximum rate is 128. So here for the silver class, I haven't given any bandwidth command as such, so there is no guarantee of sending traffic if there is congestion, but I can go up to max 128 kbps in this case. So with hierarchy HQF, we kind of put these queuing structures into data structure format, into a tree format. So with leaves and nodes. So the main, the first part is a route, which is the bottleneck for the traffic, and the way it works is the physical interface is always considered as the root of the node. And leaves is where we can classify the traffic into different classes, and in the nodes we give bandwidth like minimum bandwidth, maximum bandwidth, and other finer granular details. And if the traffic is not classified, that will go through the default class. Here we'll talk about the 3 levels of hierarchy. The physical interface is the root node, and logical interface can be divided into 2 layers, the upper logical layer versus the lower logical layer. Upper logical layer is more like PPP sessions, ATMVC sessions, etc. And the lower logical layer would be a sub interface, and the class layer where we can give bandwidth, priority, and various commands. Admission control. With admission control, what we are trying to achieve is we are not going to guarantee more than 100% of the available bandwidth. We are not going to oversubscribe it. To do this, we take into account implicit bandwidth available and any outer shapers and any rate limit, anything configured, we take into account, and we make sure that we don't guarantee more than 100% of the available bandwidth at a given point. And I just want to bring one more point here, priority without the rate. Suppose we configure the priority command without any rate next to it. That means that is going to get complete priority. Suppose I have to burst up to complete available bandwidth on an interface, then it will go ahead and burst. In that kind of situation scenarios, the bandwidth available for other classes will be starved. Enqueuing the packets. So while enqueuing a packet, we take into account the rate available, the parent node, what parameters are configured, any implicit policers or explicit policers configured, and any kind of drop mechanisms like wread, etc. that are configured, random detect. Those all are taken into account, and once we enqueue the packet into the scheduler, we don't drop the packet anymore. So queuing. In the queuing, the packet, the queue depth is controlled by dropping mechanisms like wread, tail drop. These control the queue depth, and the servicing of the queue. A packet gets serviced with the commands like priority, bandwidth, or shaper, or any kind of excess bandwidth or bandwidth remaining ratio, are the commands which will help us service a particular packet. Servicing of the queue. As we discussed earlier slide, so priority, if we configure priority, then we will be able to service the packet in a low latency queuing, which has a strict policer, so there is a very good chance that we may drop the packet if it goes beyond the available bandwidth. Minimum bandwidth guarantee, if we configure with minimum bandwidth guarantee, that means the packet needs to packet will go in if there is available bandwidth at that point within that bandwidth, and it can burst above if there is more bandwidth available. Max bandwidth, we are giving if there is no traffic in the network, then we can go up to the max of a certain bandwidth available. Excess bandwidth is how we'll allocate the remaining bandwidth or whatever available bandwidth between different classes. And most of the times, if we don't configure bandwidth remaining ratio, it would be divided equally among all the classes available. Scheduling of packets. So the physical interface is the bottleneck, which kind of creates a back pressure to all the other logical layers by oversubscribing the physical interface, which kicks the QoS scheduling. So basically, the packets enqueue to the parent and dequeue from that particular queue. So it will dequeue here, and the next packet will enqueue into this. And the congestion forms here due to the bottleneck of oversubscription. Okay, now let's look into scheduling parameters like drop discipline, enqueue, scheduler, dequeue, etc. So as we discussed in our earlier slide, enqueuing, so enqueuing of packet happens when there is bandwidth available to the next, when the packets need to go into the next queue, and the scheduler takes care of it with priority, bandwidth available, and any drop mechanisms which are there. It takes into account and schedules the packet, and once the packet is scheduled, it will go through the interface without dropping. So the same concept here we will cover. So packets will first get classified, and then we mark the packets or police or run any kind of drop mechanism, and then we run. If the packet needs to be dropped, it will be dropped before we can queue it or shape it. And I also want to bring to your attention that this is the ingress incoming, and we have shaping. This is only supported on certain platforms, on some iOSs, which is the latest ones. Usually shaping is not supported on ingress path. It's only supported on the outgoing interfaces, because the buffers are available only on the outgoing interfaces. So basically, the point I want to make it here is, if we want to drop a packet, we would drop it here before we enqueue the packet into the queue. Egress path, this is same concept. So we classify the traffic, we mark, and any dropping due to WRED or policer, we do that, and then we enqueue the packet into the queue, and then once it enqueued, the packet will go through the interface no matter what, and we can shape the traffic here, and the traffic gets dequeued, and it moves into the hardware queue, which is the FIFO queue, and we can tune the number of packets available in the hardware queue using TX ring limit. So this is a more clear picture of what we have discussed. So packets come in queue here, and then they go into different classes. So before they go into different classes, we run the drop algorithm like WRED, tail drop, or any priority or policers. And if the packet needs to be dropped, it is dropped here, and then once it passes through that, we go into voice class, video, depending on whether the packet, depending on their classification, they will fall into different categories, which is voice, video, default, or default class if it's not classified. And after that, it gets into this sub interface or next level, and then depending on its congestion, which is kicked in because of the physical interface, like the physical interface, it oversubscribes it and creates a back pressure, which kind of queues the packets here, and then the packets get to the next level and then pass on. So this particular thing is controlled by schedulers. The back pressure and how the packets should be enqueued and dequeued is controlled by schedulers. Okay, polling question. So what command should be used to allocate bandwidth for a voice traffic? You can go ahead and answer that question. And I'll proceed towards the presentation while you're answering the question. So now we'll look into the changes and feature functionalities after HQF implementation. Fair queuing. Before fair queuing used to be we used to have weighted fair queuing in the default class. Now it's been changed. So all the flows are treated equally, and there is no weighted fair queuing anymore. On the class default, whatever bandwidth is reserved, that used to be weighted fair queuing in the earlier versions. Now it is more FIFO kind of queuing. So all the packets get queued and first in, first out. And this is very helpful because we already have user-defined classes in our. We already defined what is important for us and define them in classes, and we are sending. So whatever remaining traffic is there, we want to send FIFO. That way there is no processing overhead on the router. So this all due to this, we now in the default class we can divide all the available bandwidth into equally among different classes, and if there is other traffic that needs to be sent, it can be sent in FIFO order. Max reserve bandwidth. Earlier in the iOS, we could only go ahead and configure up to 75% of the bandwidth. I see that people have answered the question, and it was the priority command. Yeah, that is correct. So for voice, we always use priority command. I'm answering your polling question. Okay. Yeah, max reserve bandwidth. So in the earlier versions of the iOS, we could go ahead and configure only up to 75% of the bandwidth available on the interface, and we could stretch it to about 99 or 100% with the max reserve bandwidth command. But now with the HQF, we have it inbuilt in the iOS, so we don't need to use this max reserve bandwidth command at all. We can go ahead and directly configure the bandwidth up to 99%. But if we go in and configure class default explicitly, then we can go up to 100% available bandwidth on the interface. So we don't need this command anymore. The command is available, but we don't need to do anything. Or you configure it, it doesn't do much. We can anyway go ahead and configure the bandwidth up to 100%. Priority queue. Earlier versions, the priority queue, we couldn't see the queue limit values on the priority queue, but now with the priority queue, we can see the number of packets available. So it gives the queue limit on the it displays the queue limit on the show policy map output. Queue limit and random detect. Queue limit and random detect are mutually exclusive. So the number of packets available in the queue with the queue limit, we can control the number of packets available in the queue. With random detect, we can drop the packets. So these are kind of mutually exclusive. So they were not available. Now with the implementation of HQF, we can have FIFO. So with that, we can have both. We can have both queue limit as well as random detect available on a particular interface. The advantage with this is we can kind of slow down and say, okay, we want to drop packets after it gets filled up to 40, and then we want to drop, and we can decrease the probability. That way we can drop the packet slowly, but we can buffer the traffic so we can slow down our congestion avoidance mechanism with this. So now with HQF, we can both configure queue limit as well as random detect on a particular class. Queuing in class default, with the fair queue, we can configure like up to 64 queues, and it's by default weighted fair queuing. But here in HQF, we do only FIFO as we discussed earlier, and there is if we don't configure class default, there is an implicit bandwidth available reserved up to 1%. So basically we can go ahead and configure up to 99% of the bandwidth on the interface. But if we go ahead and configure class default, then we can go up to 100% of the bandwidth available. Scheduling parameters. So in the earlier versions, we could configure a bandwidth command which gives minimum guarantee, and then the shaper command which gives the max bandwidth available. With the HQF, now we can configure bandwidth remaining ratio, which kind of tells how much bandwidth, if there is available bandwidth, how much I want to give for each particular class with bandwidth remaining ratio. So now if we don't give bandwidth remaining ratio, the available bandwidth will be divided among all the classes equally. But if we go in, we can say, okay, class gold needs to get I want to send, if there is bandwidth available, I want to send 10 packets of gold, 1 packet of silver, and 4 packets of bronze. Then I can put bandwidth remaining ratio as 10, 1, and 4. So physical, the queue default queue length, the physical on the physical interface, if there is when there is service policy applied, the default is up to 1,000 packets, and we can always change the buffer with hold queue command. Similarly, if there is no service policy configured under the physical interface, then we go up to 40 packets by default. Under the ATM PVC, the default value is up 500, and VC hold queue is we can change the number of packets available on ATM PVC by VC hold queue command. And frame relay map class, for that the CLI is frame relay hold queue, which can tweak the default queue length. On the SAP interfaces, there is only 512 packets we can hold by default, and there is no command available to tweak that. And on the parent child under the class, we can go and always tweak the command, put the command queue limit to buffer the extra traffic. Random detect by default, the max threshold is 40, and we can tweak that with random detect, a maximum probability command. So with the after HQF, we can now configure both a service policy under the physical interface as well as under the tunnel at the same time, and the voice will be given priority either way. Deprecated commands. So the deprecated commands now are like max buffer, shape max buffer. This command is not available anymore. The queue limit is the command we use to buffer the extra traffic if we want to control the drops on a particular class. Max reserve bandwidth. This command is available but is not of much use because by default we can go ahead and configure up to 99% of the bandwidth available. Show queuing, show queue, show traffic, shape queue, etc. These commands are also deprecated and they are not available anymore. We recommend using show policy map interface command now. So here are the references which you can go ahead and look if you want to read more about quality of service. And it's a great honor to talk to all of you. And I'll take any questions you have on the QoS from here. I'll hand over the mic to Francine.
Okay, thank you, Sarala. We have one last question that we'd like to ask. And that's the polling question. Why do I need QoS in my network? A, classification. B, avoid congestion. C, marking. D, rate limiting. And E, all of the above. So I'll give you a chance to go ahead and answer that polling question. And in the meantime, I want to thank Sarala for a great presentation. I also want to thank everyone for participating in the event polling today. We're going to answer some of your questions that our viewers have submitted today. And by the way, if you can't stay with us for the Q&A, please be sure to click on the evaluation that will pop up when you close your browser to let us know how this session met your business needs and expectations. So let's go ahead and we'll get right into the questions. And our first question, Sarala, are there best practice values for configuring queue limits?
Best practice values for configuring queue limits. Yeah, if there is voice in the network, we want to not configure queue limit or give a value, very less value, so that it's not queued for a long time. So before configuring queue limit, we want to make sure is there voice in the network. Depending on the voice, if there is voice, then we don't configure queue limit. But if there is no voice, we can go ahead and configure it. Depending on is it TCP kind of transmission, then we can stretch our queue limit to a larger extent.
All right. And the next question, what is the main difference between WRED and WFQ?
Good question. WRD is weighted random detect, which is controls the drop policies in the network. So it's a congestion avoidance mechanism. WFQ is more weighted fair queuing, which is kind of puts all the traffic into fair queuing, and all the interactive traffic jumps in front of the queue. So that is a queuing mechanism, and WRED is a dropping mechanism.
And the next question, how can I prioritize traffic based on the URL?
There is a good question, actually, very nice question. There is a command, nbar kind of a command. Under the class, you can go ahead and do match protocol, and there is an option to select a URL for that, match protocol, and then URL or www. So this is nbar kind of you can use nbar to classify URLs.
All right. And we're just going to pause for a moment for the results of the poll. You want to elaborate on that, Sarala?
Sure. So I see most of the people have answered the question correct, which is all the above. So with QoS, we classify the traffic into different classes, and then we avoid congestion. So we drop the packets before the network gets congested. We use it for marking as well. For all the incoming traffic, we mark the traffic. We use it for marking, as well as we use it for rate limiting, basically control the traffic if we don't want particular traffic to burst above. So we use QoS for all of the above reasons, which most of the people have answered it correctly, and I'm glad about it.
Okay. I think this is, how do shaping and polling differ?
How does shaping and policing differ? That's a good question. Shaping buffers the traffic and slows down and throttles back, whereas policing, we end up dropping the packets immediately after a certain bandwidth.
And the next question, is it possible to configure a queue depth on a child class using the bandwidth and not actually shaping?
Could you repeat? On the child class?
Is it possible to configure a queue depth on a child class using the bandwidth and not actually shaping?
Queue limit, yeah, you can configure queue limit without shaping. anytime. And in the child class also you can do that. Yeah, you can configure queue limit without configuring band shaping, but with bandwidth anytime. Yeah.
Okay. And how does link fragmentation and interleaving LFI work?
That link fragmentation and LFI, it's more designed towards PPP links, where the packets get like we have larger packets and small packets, so the packets needs to cut into 512 bytes and send through different interfaces. So with the fragmentation, we tell like at what point we want to fragment a particular packet, and interleaving is help the smaller voice packets to come in front of the bigger packet, so that the voice and all other packets can go faster. So basically, we divide the packets, we cut the packets at 512 bytes, and make sure the smaller packets come in front of the queue, and then send them packets.
Okay, and this is a question applying to slide 33 of your presentation. And it says queuing components is misleading. It shows that bypass happens after policing for PRIQ and WRED. Is this not incorrect? No congestion, therefore policing, dropping, etc. Also, why does it say bypass possible?
Okay, can we go to that slide? Which slide you said? 31?
It's slide 33. Okay.
So what is your question?
Let me go ahead and see if I can go back to 33 for you, so that we can...
I am on slide 33.
Okay. And it has to do with queuing components. So let me reiterate the question. Queuing components is misleading. It shows that bypass happens after policing for PRIQ and WRED. Is this not incorrect? And no congestion, therefore policing, dropping, etc. Also, why does it say bypass possible?
Okay, bypass possible. Okay, I get it. So, first thing, here the policing and WRED, this is how we are implementing in the HQF. So all the packets get enqueued after we run the WRED. We take into account any policer, WRED, and other parameters. Once we know that the packet can be queued and sent through the physical interface, that's when we enqueue the packet into different classes. So that's the first thing. And the second thing is, if the physical interface is not over, there is no back pressure. Basically, back pressure happens because of the oversubscription of the physical interface. If there is no back pressure here, that means the packets can bypass this whole QoS policies. Basically, QoS actually kicks in when there is congestion. If there is no congestion, there is bandwidth available in different classes, then definitely we can send the traffic like voice. It can go in see, queuing, the whole concept here is we need queuing only when there is more people. Like, for example, we go to a store, we get queued only if there are 2 or 3 people competing to get to a particular desk. Same concept here. If there is no congestion, there is no need for packets to be queued and go into the physical interface. There is no need for queue, then the packets can bypass. Basically, there is no congestion. Anybody who walks in can go to the front desk, or any packet that comes in can go out of the physical interface. So that's the reason behind saying bypass is possible if there is no congestion.
Thank you. And let's see our next question. How many virtual circuits, VCS, can support a service policy simultaneously?
How many virtual circuits?
Yes, can support a service policy simultaneously.
I think it is about 256, but I'll have to check that. Yeah.
Okay.
256 or anything between 200 to 300, somewhere in the middle.
Okay, thank you. And what does the aggregate and the command random detect DSCP-based aggregate do?
What was the question?
Sure, let me repeat it. What is the aggregate in the command random detect DSCP-based aggregate do?
Oh, DHCP. So in the WRED, DHCP base is basically taking into account any DHCP. We can say, okay, DHCP AF31, I want to drop the packets at a certain rate. So it takes into account the DHCP bits and our DHCP packet and drops those DHCP packets if they are queued more than particular whatever max probability, min probability we have configured. Depending on that, it will drop the packets.
And on to our next question. Are there some recommendations for tuning TX ring buffer?
Yeah, TX ring buffer, we tune it if, as we discussed earlier, if there is voice in the network and we want to control the voice packets being delayed, because packets go into the hardware on the software queue and then they fall into this hardware queue. With TX ring limit, we are controlling the queue depth of the physical interface. So we want to make sure that if there is problem with the voice, we have done everything to control, but still we are having voice quality issues. We tune the voice number of packets sitting in the hardware queue with TX ring limit, and we kind of reduce the TX ring limit to maybe 3 or so. And then this is more, tune it and then see how the network is behaving, and usually it's recommended around 3 to 4.
And is there any QoS functionality difference between the policy featured card 1, PFC1, and PFC2?
Behavior in the sense, can you reiterate? So basically we are talking about C10K here. Francine?
Sure. Let me repeat that. Is there any QoS functionality difference between the policy feature card 1, PFC1, and PFC2?
We'll have to check that and get back.
Okay. Thank you. We can get back with you on that.
Yeah.
What is the difference between match any and match all in the class map commands?
So match all is basically we have to be if we have like 2 or 3, for example, if there is an access group match and there is a DHCP setting EF, then it needs to match both. Suppose I say that I want to match traffic from access list 1.1.1 and also I want the traffic to match only if it is EF. So here I'll only match the traffic coming from only that particular source 1.1.1 and I'll not match any other traffic and also the traffic should be both EF. So it has to match both the things, then match all. And match any is more open kind of matching where I say, okay, traffic coming from a particular source, which is 1.1.1, and also EF traffic coming from any other source. So if the traffic is EF, as well as if the traffic is coming from a source, and we can have any match protocol real-time traffic, so we can add as many as needed, so it will match any. If it matches any of those list, then the traffic will be classified into that class.
Okay, and we have another question regarding the TX ring. What is TX ring limit?
What is TX ring limit? Yes. TX ring limit is basically the command to control the number of packets in the hardware queue. There is more definition to it, particles and all, but as far as its usability is concerned, TX ring limit is number of packets we can control on the hardware queue of the interface.
And why should I use priority command for voice?
Yeah, that's a good question. Voice packets are very small and delay sensitive, so if they get queued in a different queue with data packets, then the voice packet has to wait until the data packet goes out. So there is a propagation delay. So with a separate queue altogether, it goes in a priority command. So this always the packets from the priority fall in front of the queue. If there are like 4 queues, always the priority queue packet will fall in front of it.
And what is the difference between shaping and policing?
Good question. Shaping is basically we are throttling back the traffic. Whatever we are sending, we are limiting the traffic, but we are slowing down and sending the traffic. We are buffering the extra traffic. So, and we are giving maximum whatever if we can burst above that. So we try to achieve a throttling back mechanism, basically slowing down and then sending the traffic up to the max available bandwidth we can send. With policing, we are controlling the traffic, we are dropping the traffic, and we are kind of pushing it down, saying that we cannot go beyond a certain bandwidth. So basically it's limiting the traffic, the other one is buffering the traffic. Policing is limiting the traffic and shaping is buffering the traffic.
Thank you. And why do we need parent-child policy for sub-interfaces?
Why do we need parent-child policy for the sub-interfaces? Good question. Basically, on the physical interface, we have available bandwidth. We know like ATM, for example, if it's a serial interface, it's 1.5 meg. If it's a fast Ethernet, it's about 100 Mbps. With the sub interfaces, we don't know what the available bandwidth is. So we have to shape the pipe. Like the provider says, okay, I give you 15 Mbps for this MPLS circuit, then I need to shape that traffic on that. So to do that, we need to call another QoS policy, which would be a parent or a shaper. And in the class default, we apply the actual service policy and then give the bandwidth or shape that outer tunnel, which kind of gives us the outer pipe.
Thank you. And how can the queue limit be specified in kbytes and not packets?
How can the queue limit be? There is an option available when we give the queue limit to specify in bytes or in packets. So we can select whichever we want. So there is a CLI to tweak that.
Okay. And can I configure QoS in an interface that has a secondary IP?
QoS on second? Yeah, you can go ahead and configure the service policy with a secondary IP in it. It's the same.
Okay. And why is it a good idea to use FIFO in the default class?
A good question. As we already classified all the available traffic into different classes, we have a user-defined classes MQC configured. So whatever packets are available after that are basically could be from the classes which we already defined, or it could be some unclassified traffic. So we don't want to use processing overhead for the available bandwidth in the default class. So that's why we want to send all the traffic in FIFO mode.
Okay. And in which release is HQF supported?
In 12.4, 20T and above, but we recommend using 12.4, 24T and above for HQF.
And what do you mean by minimum bandwidth guarantee? What is the command?
Minimum bandwidth guarantee is at the time of congestion, we want to say that if I have 10 Mbps, I'm going to guarantee if there is congestion in the network, I should be able to send at least 10 Mbps of traffic. And the command to do it is simple bandwidth command. It can be configured in kbps or percent of the whole interface. Bandwidth percent or bandwidth value, which is in kbps.
And what do you mean by maximum bandwidth? What is the command used?
Maximum bandwidth is basically saying that this is how much I can burst to, and the command is shape and then bits per second, whatever, shape average bits per second.
Okay. And how can I adjust the minimum threshold value?
Minimum threshold. Not sure what minimum threshold of the queue, or is it the minimum bandwidth? Can you repeat the question? How can I adjust minimum?
How can I adjust the minimum threshold value?
Not sure what the question is. Basically, if we are talking about random detect, then there is a minimum probability drop value. If it's a queue limit, the threshold we can tweak it with queue limit. If it's minimum bandwidth guarantee, we can do it with bandwidth command, but I'm not sure what minimum threshold. Threshold for what? Is it threshold for drop? Is it threshold for buffer?
Maybe somebody can write in and clarify that.
Yeah.
So that we can answer that even after the webcast. Well, this concludes the Q&A portion of today's event. We will have a raffle for prizes among the listeners that complete their evaluation survey, so you can win a $20 gift card. If you have not explored the Cisco support community, you should take a moment to check out this excellent resource at https://supportforums.cisco.com. And we will be posting the recording and the questions and answers from this webcast in the community at the link provided in the chat within about 5 business days after the event. We have a couple of different webcast events coming up in different languages. The first one is in Portuguese, and it's on Cisco Nexus 5000 and 2000. It's going to be Tuesday, June 12th, and it's 7 a.m. Pacific time, 3 p.m. Lisbon, and 11 a.m. Brasilia City. So you can register for this live event through the link posted in your chat window, and that is included in the slide. Second webcast coming up is in Japanese, and it is on troubleshooting on routing protocol neighbor down the expert. The event will take place on Tuesday, June 19th at 10 a.m. Tokyo time. And you can also register for that live event through the link posted in your chat window, and that is included on the slide. The next webcast coming up is in English, Cisco Telepresence Management Suite Extension for Microsoft Exchange Installation Overview. And that's going to be taking place on Tuesday, June 26th at 8 a.m. Pacific time, and you can also register for that live event through the link posted in your chat window and on the slide. There are 2 Ask the Expert events that are currently running, and the first one is Mitigating Network Attacks. You can learn how to identify and mitigate your network attacks. The second is Ask the Expert event is Jabber Clients, and you can join both of those discussions, one or both of these Ask the Expert events, at the link that's posted there on your slide. Our presence in social media keeps expanding, so we encourage you to visit our different social media pages. That includes Facebook, Twitter, YouTube, Google+. We also have support applications for your iPhone, iPad, so you can visit those at iTunes and download those. We also now just have a new Android technical support app for your Android supported devices. We are on LinkedIn, and you can also subscribe to our newsletter. Before signing off, please take a few minutes to complete your evaluation of today's session. So this will help us address your business needs and interest in the future. We also have communities in other languages that you may want to visit. So that's communities in Spanish, Portuguese, Japanese, Polish, and Russian. So this concludes our session today. I want to thank our expert, Sarala, for sharing her expertise with us. I also want to thank the behind-the-scenes experts, Rajat, Satya, Saurabh, and Raymond, for answering some of the technical questions. I want to thank all of our listeners today, and have a great day.
Thank you, everyone.